I'm Rob Penzer. I'm the Associate Director of the Helix Center. Welcome. Before we start with today's program, I have a few announcements. Some upcoming roundtables. On Saturday, November 5th, we have Autism and the Mind-Brain with Andrew Gerber, psychoanalyst and medical director of Austin Riggs, Nushin Hajikani, who's associate professor in radiology and director of the Neurolimbic Research Laboratory at the Martini's. Should be Martino's. Sorry, that's autocorrect. I guess there are some interesting neurolimbic research at Martini centers also, but it's the Martino Center at Mass General. Craig Newsheffer, who's the professor of epidemiology and biostatistics and founding director of the Autism Institute at Drexel University School of Public Health. Jeremy Veenstra Vanderweel, who's the Mortimer Sackler Associate Professor of Psychology at Columbia University, and Martha Welsh, Associate Professor of Psychiatry in Pediatrics and Pathology and Cell Biology at Columbia University Medical Center. On Saturday, January 28th, we hope you'll join Alberto Manguel and other scholars for The Library as Reality and Metaphor. So please follow us and like us on Facebook as well as on Twitter, and you can visit helix.org for further updates. So today's program, I'd like to introduce our speakers today. Michael Bess, and if you could raise your hand so people recognize you, who's Chancellor's Professor of History at Vanderbilt University. Ned Block, Silver Professor of Philosophy, Psychology, and Neuroscience at New York University. Jeffrey Kephart, IBM Distinguished Research Staff Member, Symbiotic Cognitive Systems, and IBM Academy of Technology member. Francesca Rossi, Research Scientist at IBM Watson Research Center and Professor of Computer Science at the University of Padua. Unfortunately, David Hansen, who was going to be joining us from Beijing via Skype, took ill, and he sends his regrets, so he won't be participating. So I'll just, by way of a slight introduction, we're going to be talking about embodied artificial intelligence, and we understand that intelligence now requires a body and can't be understood by simple algorithms alone. And one of the questions that I might also want the panel to consider, are we thinking about sort of an artificial, constructed evolutionary developmental biology when we talk about embodied AI? Are we thinking of modeling things in terms of the way that in organic systems, development and evolution play a role in the attainment of intelligence? So with that, we'll start.
Whoever wants to get going can get going.
Okay, I'll start. So I'm not sure how to answer that question, actually, because when I think of embodied cognition or embodied AI, and we've discussed with Jeff many times already, I think of an AI system that can help people make better decisions, so that work in symbiosis with people and help them do better whatever they have to do in their private or professional life. And so rather than, maybe I didn't give much thought at this ideological interpretation of the artificial intelligence, but more I see the embodiment part of AI as a way to facilitate the interaction with these human or humans that are going to work together with the system. So I see this embodiment as a way to help in this interaction. So for example, we are thinking about, also with Jeff, about cognitive rooms, like this one, an example, for example, where people, suppose we are, people not just discussing here, but are, here a committee of people having to make a certain decision, and we need help in gathering the data and discussing and, resolving conflict and so on. And the room itself can help us in doing all these tasks. And the fact that the room can be aware of who we are where we look at, where we point, and what we do during this discussion and decision process can help, for example, interact with this AI system by facilitating the conversation in the most natural way with the AI system compared to what could be done with just a software that is in our laptop and is not aware of the context or who is interacting with it and so on. So that's one way I see embodiment is going to be really helpful in increasing the artificial intelligence, but also in increasing the capability of this artificial intelligence to interact and help humans.
So I agree with what Francesca says, but I want to introduce another issue that sometimes comes up under the heading of embodied cognition, and that is whether results about cognition in the body show that the difference between the body and the brain isn't as, the border between the body and the brain isn't as important as people once thought. Sometimes the word magical membrane is used, that people have thought that the brain is really what's important to cognition and not the body, and there's a magical membrane around the brain, but it's a mistake, as many people think. Maybe I can go to the issue that you raised about development and evolution. So we have many systems that co-evolved and developed with respect to each other, but we still think there's a really important divide. Like, take the difference between animals and plants, for example. Animals and plants co-evolved. So, color of plants and color vision of bees supposed to have evolved together. But still, we think that animals and plants are very different kinds of things, even though they interact. In philosophy and in cognitive science, I think a major issue, which no doubt will come up, is the difference between a causal relation and what philosophers call a constitutive relation. So here I'll give you a sample experiment that is often quoted by people to show that there's no important difference between that the body is part of the mind or something like that. So if you put a blindfold on people and you ask them to point to things in the room, and people can do that pretty well. Now you give them a harder task. Put a blindfold on and ask them to imagine turning 90 degrees to the left, and then point to everything in the room. People don't do so well on that. But here's a third thing. Ask someone to actually turn 90 degrees to the left. They turn their body and then point to things in the room. People can do that perfectly well, again. So the difference between imagining turning and actually turning has suggested to some people that the body is actually part of our cognitive mind. But I'm not so sure that's a good conclusion, because there's another way to think about it, which is that we have mental maps, and that's an internal mental representation, and we automatically orient or try to orient our map to the room we're in. And so the person who's asked to imagine turning to the left is both maintaining a mental representation of a rotated room and the mental representation of the room that automatically is computed, and that's two things to do. And so, of course, you're going to be worse at it than if you just turned your body and then only have one mental map with one orientation. So rather than showing that the body is part of the mind, it just shows something about the effect of the body on the mind. So that's a causal relation rather than a constitutive relation. So the body then, on the view that I would be more in favor of, is the body plays an important causal role. So I think the things you mentioned, it can help us a lot. We wouldn't get very far without a body, but and the room can help us too. But that doesn't mean that these things are actually part of the mind or part of the fundamental basis of the mind.
I think you were talking about, your focus was largely on embodiment and its nature in humans, and Francesca was focusing on how can we use embodiment. Sort of at IBM we think of building things, creating things. You're trying to understand
I'm a philosopher and you're a computer
You
scientist.
understand things, and we just build them without understanding. But I think you bring up some interesting things. You were talking about some of the difficulties that we humans face, some of the interesting corners that you get into as you probe the limits of what people are able to accomplish cognitively. And as Francesca was saying, one thing we're trying to do in our laboratory is to develop, to think of embodied AI as a way to create partners for humans in solving cognitive tasks. And we believe that for us, embodiment is helpful because our belief is that people have an easier time if they're interacting with something that has some human-like qualities to it, something with which we can engage in a sort of conversation or maybe a more multimodal form of conversation. And so that's why we're exploring both one part of what we're exploring is creating software agents that are super competent cognitively in areas where people are not so strong cognitively. There's plenty of places where, or areas in which people are very strong cognitively, but there are plenty of places where they're not. Decision making being one of them, as you well know, dozens of cognitive biases have been cataloged, starting probably, well, at least with Tversky Kahneman, as far as I know, but maybe further back. So we tend to focus on those areas where we can have an easier time creating strong cognitive agents. And then the second part is to endow those agents with the ability to interact with us in more human terms, not through a mouse and keyboard, but through speech and gesture and combinations thereof.
I was somewhat surprised, Francesca, when you gave that example, because I always have assumed embodied AI meant, kind of the Rodney Brooks point of view that the robots will become smarter more quickly if we let them interact with their surroundings and sort of learn by themselves and build their knowledge practically through their own experience. But what you're saying is embodied AI is maybe this is similar to what you're saying, an extension of our body. I mean, the room that you're describing is not just a better interface. It would also be presumably offering us extensions of our own thought process, suggesting new ideas to us that were logical inferences or associative connections that we might not have thought of?
Yes, it's going to, I mean, the idea that this embodied environment working with us will be proactively working with us, not just reacting or answering like you can ask Google, find me something, or you can ask Siri, find me something, but we just proactively tell us, I think that at this stage of the discussion, you want to have this data, so let me give it to you in the form that is easy for you to handle. So very proactive,
But those takes on embodiment are not incompatible.
Right.
We are focused on how do you create an embodied agent. One means to arrive at that is through a sort of evolutionary process where you build something, a robot or maybe some other thing that is situated in the world and learns through experience. Mm-hmm. And that's one, and we aren't doing this, but some of our colleagues at IBM are studying this approach to learning from the ground up. And I'm aware of other efforts around the world. There's Stephen Levinson, I believe, at UIUC in the engineering department there, who's also studying, giving just letting robots be in the physical world and let them learn through experience. And I think that's a very interesting approach.
Have we already built a room like this? Are we already sort of trying to experiment
Yes.
by putting people into these kinds of interactive rooms and letting the system?
For the last 2 or 3 years, we've been working on this. Our first focus, our first class of cognitive tasks that we're working on, as Francesca was saying, revolve around decision making. And so we develop agents that are able to help elicit from us what are our preferences, that's one thing that I think is important. Sometimes it's hard for us to even know our own minds. What are our preferences? To tease that out, there are agents that we're developing whose purpose is to do that. But then,
how does that work?
well, I think there is already, I think here there is already in the realm of decision science a lot of techniques for doing this. For example, for assessing risk tolerance, there are various questions that can be put to people. Do you prefer A or B? Or how much of X would you trade for Y? Things of that sort. It's not perfect because if you ask the questions in different ways, of course, people are subject to cognitive bias, and you get inconsistent answers. But at least if you can ask people those questions in different ways, you can look at the inconsistencies and have a chance to correct them. So that's one area, but also cognitive agents can do things that much more readily and easily than we can. Simulation, optimization, collaborating with humans in building models of risk and uncertainty. These are some of the things that we're starting to explore.
And this presumably is relevant also to this notion of nudges, which is like when they pass laws that put taxes on soft drinks, so people are nudged not to drink too many soft drinks or make the bottles smaller. Presumably, you could program the AI or encourage the AI, incentivize it to give you nudges in a certain direction when it's giving you suggestions to try to extend your thought process.
I think that programming and the incentives, I mean, if I'm an individual decision maker, yes, there are incentives, but the incentives affect every individual differently because it's a matter of our personal utility function. Mm-hmm. So I wouldn't put in the hands of the developer or the programmer that encoding. I would rather have the agent interview me, the user of it, so that it understands my preferences. And I don't think this can all be done up front either. I don't think my 25-dimensional utility function can be drawn out of my head very readily. But in the context of making specific decisions, over time, I think the system can get a reasonable feel for what are my preferences and trade-offs. And now, Francesca is an expert in collective decision-making, which is an area we haven't really probed yet, but that seems like a very exciting space to start
So instead of helping
entering.
just one person, we want to help groups of people making better decisions, which of course has to do not just with eliciting individual preferences, but also how do you put together these preferences of different people, and again, try to resolve conflict, try to, check, possible, negotiations and conflict resolution techniques and preference aggregation to get to a collective decision. Like, think of a hiring committee, that has to decide one among a list of candidates, and each person, of course, this is not just based on preferences, but on the actual value of the candidates. But, there may be actual, individual subjective preferences as well, given the same kind of skills of several candidates, and in this context there can also be in many of these contexts there can also be some guidelines to follow in a decision process. For example, when you hire somebody, you have to make sure that you're not biasing based on gender or race or whatever, religion or whatever. So there is also a role for these cognitive embodied systems to actually help, follow these guidelines, these professional codes, code of ethics, and possibly being even more able than the humans to follow them and alert when there are deviations according to these guidelines. So that's also another part of these projects that we are, studying right now, that to embed kind of ethical principles and professional codes into these decision support systems. And again, we think that the embodiment of the support system is essential in making this, the best way to interact with humans also from this point of view.
So is this to eliminate the individual prejudices, or in other words, or is it replacing it by some other standard of selection? Or, in other words, if you are going to choose a person, in real life, you have certain criteria on which you base it. And sometimes you are lucky and it works, and sometimes you're not lucky and it doesn't work. And some of the criteria you choose, you only realize after the fact that you had those criteria and you shouldn't have let them influence you. So how does all this come into the picture? Does it clean all this up and just becomes very neat and factual, or?
Well, I think it depends on the scenarios that you are considering. Sometimes you need decisions that may, may allow people to have time to reason about the decision. Sometimes you are, for example, in other scenarios when you need a very fast decision, like, you're helping a doctor to make a very critical decision in a surgery room. So then you need somebody that is not going to have any bias, is going to be very factual and very quick in deciding what's the best course of action in that particular moment, because that's a very critical, and life or death decision. But in other cases, I think you could, really make humans more aware of their biases. So help humans not just, think afterwards, oh, if I would have done that way, but the system can actually help you during the decision process to discover that you have different courses of action, that, maybe by remembering other decisions that were made together with that system in the past, it can help you. But look, I think that you also have these other criteria, because in the past you showed that preference that makes me think that maybe you want to follow that path and not the other one. So I think that there is a role for this embodied environment to really help us be more, aware of our, criteria, of our biases as well. But of course, one has to be careful. I mean, these systems are not perfect, will not be perfect, will never be perfect. So we also have to be aware of their limitations. We have to trust the system, but with the right level of trust, and so we have to, over the interaction over time, we have to learn what their limitations and possible biases are, because there could be biases, maybe even unwanted, into such systems as well.
I'd like to distinguish clearly between preference and bias.
Yeah.
I think the systems we're trying to develop are designed to, in the end, really understand human preference better and reflect it better, subject maybe to social norms and the like. But we're trying to reduce bias, which I see more as those annoying things in our reasoning process that cause us to deviate in our actions from what really is optimal with respect to our preferences.
But sometimes you choose something for the wrong reason and turns out to be very good.
But
Could
that's
be.
still a bad decision,
Serendipity.
because you just got lucky, but I'll still call it a bad decision.
This emphasis on getting the machines to help us figure out what we really want, or maybe it fits with something that Francesca and I heard this past weekend. Francesca spoke at a conference that David Chalmers and I we have a Center for Mind, Brain, and Consciousness. We ran an Ethics of AI conference. And there were talks there by Stuart Russell and Eliezer Yudovsky, which went into the issue of, we were just talking about earlier today, of how you get an AI to have a goal. And they argued very strongly, and I thought very persuasively, that you cannot just put a goal in a machine and expect to get out of it what you want. And the example they used was the Sorcerer's Apprentice, or Yudovsky used, which is the slightly shifted in the machine direction, where the apprentice engages a machine instead of a magical broomstick. And the idea was this: you tell the machine, here's your goal, make sure that the cauldron is always filled with water. Okay, so the machine thinks, well, the way to maximize the probability that the cauldron will be filled with water is to always have it overflowing. And then the machine reasons, but these people will not like the water to be all over the floor all the time, and and they will want to turn me off, so I have to disable the off switch. And furthermore, they may try to damage me so I can't keep doing it. So I better make more copies of myself. So the idea is just giving it a goal, making sure the cauldron is always full, isn't going to get you what you want, because any goal can be understood in a machinish sort of way that isn't the way you would expect a person to understand it, and you can't really, there's really no way around it, other than, and this is the proposal that a number of these people were making, which is the machine really, what you should really tell it to do is to figure out what people want. And this fits with this emphasis on the collaboration between the machine and the person that you two are both emphasizing.
My hope is that we won't spend 10 years designing a software agent that keeps cauldrons filled to the brim. If we were to do that, I think it's very possible that we would arrive at the state of affairs that you described. But we develop things incrementally, for one thing, in our development cycle. And also, I believe that for a good long time to come, we are going to be not just delegating out to AI and walking away, going to the beach and coming back a week later to see what happened, but we're going to be actively engaged. I think we're going to see what is happening, and I think we have at least a chance, either as developers or users of the system, to intervene. At least that's my hope. I do know that machines can be thousands of times faster than people, so I may be wrong in certain aspects of this, but that is my hope, that we would, through our engagement with the system, kind of see what's going on and say, wait, that's not what I wanted. Hold on.
If I understand you correctly, both of you are now talking about an AI system that is somewhere in the spectrum between today's AIs and artificial general intelligence or a human level AI. It's somewhere below that, right? In the sense that you can give it this set of instructions. It's motivated to obey those instructions, but it does so actually stupidly. In a way
It does it in an alien way.
In an alien.
In an alien way.
Yes.
So
Right.
So as we were also talking about earlier, for humans, there's a cognitive background that no one ever states, and maybe it would be impossible to state everything.
Right.
You know that the floor won't bite you.
Yeah.
There are all these, the word background is actually often used in philosophy for this. It's just a shared set of what you might call assumptions, but it's not clear that they could ever be codified. And the machine would, depending on how it's made, have a different background from us.
So the goal would be to get a machine that is raised like a child through all the socialization, experience.
Yeah.
I mean, if you watch a small child learning how to grasp an object and learning, oh, if I don't apply enough pressure, it falls to the floor. Child isn't going through that conscious process, but it gradually through the years gets all this background accumulation. Would we then have an AI that is operating?
There was a problem raised with this in the symposia that I'm talking about, which is that what the machine develops depends not just on its environment and the skills it learns, but the kind of processing that it starts off with. And if you had a machine which at some point in its development realized these people have a quite different idea of what to do than I do, but if I reveal that difference, they will be upset, and they'll try to operate on me or whatever. So I better pretend to have the assumptions that they have. So that point was made in one of these symposia, and it's a little troubling, because if you make a machine that's maybe smarter than you know it is, it could be fooling you.
That would be a human-level AI, right? It could deceive you.
One of the points made in the symposia is that you might move from human level or subhuman level to better than human level rather quickly without really realizing it. And another point often made in this context is that the points at which this is most likely to happen, when people are most likely not to be taken care of that border, the dangerous border, is in contexts where there's competition and there's race. For example, in wartime, and you're racing with the enemy to develop the most sophisticated war machines. The sophisticated war machines can get away from you.
Yeah.
Well, I think you're talking about a sort of possibly a phase transition. You're talking about emergence.
Yeah.
It is possible, and people do use that language when they talk about the singularity. That is a concept of phase transition and emergence. I don't know if I believe in it or not, but it's a possibility one has to consider.
What is your take on it? Does it sound so sci-fi-ish that it's hard to? Are we so far away from it that it's like silly to worry about it, or?
Even if we're far away from it, it doesn't seem like it's silly.
We should say what it is for people who've never heard this term.
The singularity is the idea that at a certain point, artificial intelligence will outshine human intelligence, and it'll get to the point where humans are basically not good for anything, at least from the point of that alien machine intelligence. So there are naturally concerns about this sort of thing happening. And this is not, we all know about this, at least if we've watched any science fiction movie at all. It's there for us, that sort of possible future is there. I don't think I have any special insight into this. If it happens, I think it's a way off, but that doesn't mean we shouldn't be worried about it. Now, something like the death of the sun 4 billion years out, that's a little hard for me to get emotionally involved in, but this is closer in. So even if it's my great-great-grandchildren, I still feel some level of, it's something we ought to concern ourselves with. What do we do about it? I think we don't just blindly go ahead and create technology. I think we do have to think about it and have an eye on things. And I think some of the efforts like what Francesca is doing with ethics and AI are very worthy things to be doing now, to have us thinking about the implications along with our development of the technology.
I think the thing that makes the singularity somewhat, gives one a little shiver is the thought that maybe we could one day make machines that can make machines that are smarter than they are. And maybe those machines will be able to make machines smarter than them, and so on. So the idea is you could reach a point at which it takes off.
And it takes off exponentially at that point.
Yeah.
That's what people think, when the threshold of human level intelligence will be passed, some people think that it will actually, maybe it will take a long time to get there, but then at that point it will. But I would be actually, of course, one can have, all sorts of speculation and envision all sorts of scenarios of where, when and this will happen and how will happen and what will happen at that point. But I really think that, what Ned was saying, that we don't need to wait for that to happen, if it will ever happen, to have concerns about the fact that intelligence systems, even very narrow and very specific for a task, so no human level intelligence, because human level intelligence means you're very broad and you can adapt your intelligence to various tasks on everyday life. Even very narrow and very task-specific AI can, give, undesired, behavior, like the one that was in the example that Ned made. So we have to make sure that, either, we can tell exactly what we want without leaving everything out, which sounds, again, very difficult, because we don't tell each other, yes, do this, but also take care of this, don't do that, and so. Or they discover them themselves by observing us, and then inferring what the principles are, what the common sense reasoning capabilities that we use now in our everyday life, they should use as well. But anyway, there should be, or a combination of these two things, but there should be some way to provide them with these goals that we want them to reach, but in a ethical, fair, reasonable, common sense reasoning way. So this is something that is, it may sound strange, but this is something that it's not been considered a lot in the history of AI, because all the machines until very recently were very narrow, very smart in doing that simple thing that, that small thing that they needed to do, but they were not capable of doing many other things. So if you want a machine that can play Go as good as possible, play chess as good as possible, then you know what goal to give the machine. And you don't need to specify many other, collateral things that he should be careful not to harm people, or that's not the point. It's not relevant. He should play chess as good as possible. But so in all the textbook that you can see of AI, there is always the assumption that you can easily give a machine the goal that it should achieve. And why now we realize that the more the machine get into the real world scenarios, and they have to do with the uncertainty of the world, and they have to take care of the things that can happen in the world while achieving the main goal that we give them, then really we need to be careful that they also are aware of the fact that they should not do this and that. So another example that Stuart Russell always gives is that if you leave at home your kids with the butler robot taking care of them, and you tell this butler robot to cook dinner for the kids, and the robot opens the fridge and there is nothing in the fridge, but he sees a cat walking around in the house. But there's some that you don't want the cat to be the dinner for your kids. But if you just say cook dinner for your kids, you have to be careful that you also say all these other things, that you should not do, Or I don't know, if you have your self-driving car and you tell the car, bring me home as fast as possible, period. And then, yes, okay, but you have to make sure that you don't run over anybody, you don't make me car sick because you go too fast, and so on. So all these other things, are part of the goal. But, we still have to understand how to communicate this to a machine.
Well, I think part of the answer that you were getting at is, in your very first comment, was could these robots evolve? And that brings up the question, you're talking about AI and ethics. Right now, we are thinking about ethics and AI, but maybe part of the world experience of these robots is we bring them up and we teach them. Humans teaching robots, and no, that's not good behavior. This is what we do. This is the way we do things. And it's a possible approach to having them grow up understanding social, human social norms.
Yeah, but hopefully it doesn't take, 18 years like for humans.
Well, I don't know what to hope for.
But given that there are also unanticipated results from that, is there, just going back to my initial, is there a potential danger in trying to model artificial intelligence development on what we understand about humans, and mimicking the developmental steps, or creating a kind of evolutionary potential in them?
You mean what if we're bad parents to our AIs?
In a sense, or we're ignorant parents. We don't know all the parameters, right?
Humans start off with a huge innate component to all their cognitive abilities. And you couldn't expect to get the same results with a machine that doesn't have those innate components. So
For example, it has been, I think, recognized that even very small kids, like 3 or 4 years old, they have an innate nature to cooperate with others.
That's right.
And nobody teaching them, but they cooperate with each other. They help each other. they help adults, they help other kids, and I mean, machines don't come with this thing, or others. So, I mean, there must be some other way, to teach them or to make them, have these capabilities, which is different from what we do for humans.
I suppose this is true, because if you did the thought experiment of, let's bring up an ape in our household, you could treat it just as you would your child, and it might end up somewhat different in its behavior.
That's in fact the issue that Francesca just raised is actually directly relevant to this, because apes don't have this cooperative impulse. So Felix Warneken showed with babies,
I know him very well.
That a 2-year-old who sees a person go to a cabinet and put things in it, and then goes to the cabinet with a thing too heavy to occupy both hands, the child will spontaneously go and open the door. Many experimental approaches to monkeys and chimps show that they do not tend to do this kind of thing. In fact, they don't. If there's food involved, they really seem to be, especially competitive, and
Well, there's learning and there's evolution, and I wonder whether on an evolutionary timescale we can get whatever it is in the hardware or firmware, better, aligned with humans. But another point I would make here is that on the one hand, we would like the embodied AI to understand something of our world, so it can know something of our norms and ethics and all that. So that would indicate or dictate that we want to bring it up as one of our own. But on the other hand, it shouldn't be the case that the only embodied AI that makes any sense is a humanoid-like thing. So I don't know how to reconcile that. Certainly the cognitive room that we were describing is not humanoid at all. We talk to the room, and it talks back to us through the speakers, shows us stuff through the displays, but there's nothing humanoid there, and there are plenty of robots out there that are not humanoid either. I don't know how to reconcile that.
So are you saying it's not possible that we get to a point where they recognize emotion?
We can, to some limited degree, recognize emotion now. It's trained. I mean, it's through text, facial expression, tone of voice. You can train a machine to classify human emotional state into, a small number of discrete states: happy, sad, disgust, anger, things like that.
So why would they then not be able also to have them, in terms of what you were saying, in terms of singularity, recognize certain things are not to be done, certain things could hurt somebody, and so they shouldn't do it? In other words, have a control system built within it.
But the Source's Apprentice example is meant to show that there's no goal that you can give it that couldn't be understood in a way that goes counter to what you wanted. So it's really difficult to see how to put that into a machine.
The possibilities for screwing up are infinite.
Yeah, that's right. Yeah,
in variety.
But that's true with humans. So.
No, but humans have this. Humans have this background of understanding. I mean, not all humans. There's a class of psychopaths that don't have.
We are talking about humans today, but humans in the past.
Yeah.
Where killing and all sorts of putting fire on people's homes and so on was normal. So it has evolved to the point we are here. So when we worry about singularity, why aren't we also thinking about that it would evolve the same way humans have evolved?
Well, it may, but that's a future. By
creating a god of AIs, I don't know, but somehow creating the same thing being part of the evolution of it.
Well, here we get into what is our feeling about the possible eventuality of a singularity. We could take the view that, well, we humans in our present form are maybe not going to be part of that future, and that's that makes us sad. Or it could be, well, some essence of us is continuing forward. Just, it's part of the natural evolutionary process. We could take that detached view. I don't know if I can get myself there personally. It's a, maybe it will improve itself in some machine form and become some perfect being. But is that connected to me? I don't know if I can connect that to myself. So I don't know if I feel happy at that prospect. But it may be that we sort of, some have suggested that we're not, the distinction between human and machine is going to become fuzzy to the point where it sort of doesn't matter anymore. I mean, as we have artificial limbs today that are getting better and better. Someday they'll be seamless and you won't even know the difference. But then the same thing could happen to our brains. Maybe parts of our brains start getting replaced by something mechanical, or maybe it becomes squishy and biological-like. Over time, maybe we just augment our bodies and our minds, and we sort of meld together, human and machine, and then it's just part of our projection into the future. So there are different views one can take of this.
Part of the implicit distinction that I'm hearing is, do we want these AIs to be tools or instruments, or do we want them to be agents? And the paradox is that you want them to be agents because if they're mere tools, they're going to do the dumb thing. You're going to give it commands and it's going to misunderstand and do harm. So you want them to be more agent-like so that they understand your intentions, or you try to get them to do that. But the more agent-like they become, the less you can control them. Ultimately, a real agent, what distinguishes an agent is they can take initiative and then start doing things that they decide, having their own priorities.
The way out of that, at least in today's world, is to, they're both more, we're using them because they're more intelligent than us in certain ways,
Yeah.
But I view them as idiot savants.
Yeah.
It's some of both.
They're still instruments at that level.
And yes, they're in narrow ways, cognitively stronger than we are, but in narrow ways. And so,
like a pocket calculator.
Beyond pocket calculator, but I wouldn't ascribe any cognition to a pocket calculator particularly. I would say that these are tools that really augment our cognition in a more significant way, but they aren't in their own right necessarily a fully autonomous, certainly not an artificial general intelligence. We're not going to be there for a while.
Like a consultant, like an expert in something that you need for your job, and you consult with, and you are going to make the final, decision about what you need to do, but you consult this expert who is going to help you because he has more knowledge and he has more skills for that particular thing that you need to do. So machines will be much more capable of us in certain things, as Jeff said, like in handling, reading a lot of data, a lot of scientific articles, a lot of, information that you will never be able to read in your whole life, and then summarize it and give it to you, the parts that are relevant to what you have to do at that particular moment. But pocket calculator does not give the best idea, I think, because it's very deterministic, so you give the numbers and always you give the same numbers twice, it gives the same result. While here we want somebody that can take care of the uncertainty of the world, of the incredible number of scenarios that can happen, and also that it has its own ways of dealing with these lines of conduct and maybe and probabilities, probability reasoning, and so that maybe in slightly different scenario, it gives you a completely different, suggestion of what to do.
Sensitive to context.
Yeah.
But of course, as soon as somebody gets a line on how to give them a general intelligence, since there will be no stopping it. And then we could enter into uncharted territory. So we should really be thinking now about that transition.
I think earlier you gave a very good example when you were talking about the singularity of the notion that suppose a machine can create a machine that is slightly more intelligent than itself. All you have to think about is if a machine can create a machine that is 99% as smart as it is, then you can take it several generations ahead and it'll just peter out. But if you can make a machine that makes a machine that is 1% smarter than it, it's going to be exponential, a positive exponential instead of a negative exponential. And that's where you get a sharp phase transition between, don't worry about it, and oh my God.
And also, people, I think, are kind of concerned about that scenario because differently from humans, machines can replicate themselves instantaneously and almost with no cost, at least for the software, So then, you have this exponential, not just for one machine, but for a very huge number of machines. But again, I think that, I don't know what we can do now while envisioning that faraway scenario, what we can do now, thinking of that scenario. But we can already do now and work now for narrowly intelligent machines to actually help them behave in the right way. And I think these efforts will also help when and if that general intelligence will come out.
And maybe we can get AI researchers to behave in the right way too. I've heard that
of course.
people have taught courses on AI and ethics through the medium of science fiction. Because science fiction has plenty of cautionary tales in it.
Well, there's a number of TV programs right now that are exploring this border. There's Humans, Westworld.
Yes.
My problem as a historian is I've tried to envision what would be plausible scenarios if we decided that we needed at some point to restrain the advance of AI as a science. And I can't find any that would be, in my mind, that would be successful because, as you said, we live in a competitive society and a world that is not unified. And if either one company competing against another company or one nation competing against another nation, anybody who gets the first past the post in terms of getting one of these artificial general intelligences is going to have an extremely powerful advantage. And so there's an incentive built into the very structure of our political systems and our motivational systems to compete, and it's kind of an arms race sort of mentality. Whether, even if it's not at war, it could be some other, it could just be just sort of the first past the post gets more powerful.
I wonder, from reasoning from history, are there any historical examples of being able to suppress a technology? The only thing I can think that at least goes slightly in that direction is probably nuclear proliferation. The U.S. got to that point a little bit before Germany, and we used it and then backed off.
The few examples tend to be cautionary in the other way. The Chinese at one point banned large ocean-going vessels for a while, a couple centuries. And all that did was it postponed the inevitable, because eventually other people built big boats and came to China. And so in the competitive world, the game is set up in such a way that if you have to keep advancing, because otherwise your neighbor is going to advance past you, and then you'll be at a disadvantage. So there have been attempts by people, you think of the Amish, they've been able to do it because they pose no threat to anybody. But in cases where you're actually getting competitive power or advantage in a competitive situation, sooner or later, the pressure makes, would there have been an atomic bomb if World War II hadn't happened? Probably within 20 years. The war accelerated that process, but probably by 1960, somebody somewhere would have figured out The Germans were already on the way to doing it anyway.
I read a wonderful book by a military historian, John Keegan, that went through a number of phased transitions in development of weapons in which there was a sudden advance in either defense or offense. And one that sticks into my mind is the development of a much better cannon, which interacted with the defense of the time, which were these high walls. And so for example, the fall of Constantinople in the, what's that, 1453, I think, was due to the fact that the Turks perfected a cannon that allowed them to undermine the walls. And then and then they would just fall. So once this happened, defensive walls in cities all over Europe everybody realized that the cannon made their walls obsolete. And what they needed was wide, thick, very thick, and some that can be low walls, but much thicker. And they were building new walls to for more than 100 years, all the cities, the walled cities in Europe. He even quotes a wonderful letter from Michelangelo saying, because he was selling his services as a wall designer, saying, I don't know much about painting or sculpture, but I really know about building walls.
But it's true that we live in a very competing world, but I think that, little by little people are starting to realize that, especially in this, understanding the issues in the advancement of this very powerful technology is something that should not be part of the competition, understanding how to address these issues, like, for example, maybe Ned remember that I mentioned that last week, that 2 weeks ago it was launched a very, I think, interesting initiative where 5 of the main companies developing AI, which is IBM, Google, Facebook, Amazon, and Microsoft, they decided to get together and understand together what it means to develop AI for the benefit of people and society. We will try to engage with everybody else. It's not just a company kind of thing, with non-corporate members as well, non-profit organizations, scientific associations, individuals, society in general. But we really think that we should not hide that there may be issues in this development of this very powerful technology, but the technology is so powerful, it can be so beneficial for everybody that we have to work together. Even companies that are, as you may know, competing a lot in the marketplace, but they think on this, there should be really collaboration. And I think this is, of course, doesn't mean that maybe other companies or other countries are not going to compete, but still, these are very companies that can influence a lot all over the world because they are all, used by, billions of people everywhere. And I think that this can start really a very collaborative environment where these issues are discussed, addressed, solved, and understood how to best trajectory for AI in the future.
But don't you think that if one of those 5 companies makes a real breakthrough, what's the likelihood they're going to actually share it with the other 4?
Yeah, but
but I don't know about the other.
No, but the idea is not to share, new software or new advances, but to share the best practices and how to deal with, making AI, of course, in a competing environment, more and more, smart, but in a collaborative environment, making it smart, but in the right way. So it could be that one of these companies is, making tomorrow a very big advancement in AI, and of course it's going to be his own result and not the result of the other ones. Mm-hmm. But, we want together to understand how to make whatever advancements is going to be made by anybody in the best way for the benefit of everybody. And I think that that's really, needed a lot, a collaborative environment on these issues, even among entities that are naturally competing because of their business model, of course. Yeah.
It's really encouraging. I mean, it's similar to what was done about a year and a half ago with genetic engineering technology, the new CRISPR-Cas9 pathway for modifying genomes, and they convened a second. The first such conference was with recombinant DNA technology, the Asilomar conference in the 1970s, and voluntarily the leading figures in this field met a year ago and are again, saying let's consult with each other, let's establish basic ground rules and best practices. I didn't know that this had happened with AI. I mean, it needs to happen with synthetic biology. It needs to happen with all these nanotechnology, all these potentially disruptive, but potentially also enormously beneficial technologies. It is incumbent on the people doing it. I remember in 2000, I think it was, there was an article published in Wired by, I'm blanking on his name right now. He said, "Why the future doesn't need us." What's his name again? He was a computer programmer who basically said, "I'm leaving the field because I can no longer ethically continue to something which I think is going to lead toward the singularity." Pardon? No, it wasn't Jared Lanier. It's Ray Kurzweil. No, it wasn't Ray Kurzweil. It'll come to me, of course, after. But it made a big stink in the sort of technology community because he was saying, "I'm taking an ethical stand," and implicitly he was saying, if you don't also quit doing this, you're doing something fundamentally morally wrong. It's like continuing to work on the atomic bomb or something like that.
Yeah, but quitting, it would also not allow us to get the real benefits of this technology.
Exactly.
For example, just one in healthcare.
Exactly.
And cure cancer,
Exactly.
solve healthcare issues, and so I don't think we should quit. We should continue in the best way.
Exactly.
Yeah, I think to state the obvious, if the most ethical programmer quits, the population of programmers becomes less ethical.
Somebody would have very quickly
I
taken
feel the
his
need to reiterate something that you mentioned in a glancing way, but best practices are great, and it's great to formulate them and share them, but it's in a competitive environment where attention might not be paid to them, and I think especially in if there's a war-like situation. Whoever is making an advance might not pay that much attention to the best practices if they think they're going to, they're going to defeat the enemy.
It doesn't even need to be competitive or malicious, I guess. It can be accidental. Oops, sorry, I didn't realize that would happen.
We're rushing.
It could even just be some emergent phenomenon that it would have been difficult to anticipate. And I guess this brings up the question of liability for AI as well. Who's responsible when something goes awry?
There's been a lot of talk about hacking. So is it still possible, for example, you said these 5 companies have gotten together. Is it possible, is it not, are you still able to keep things hidden from the other companies if you don't want them to know about your, in other words, isn't it possible with sophisticated technology for, let's say, Amazon to know exactly what IBM is doing and vice versa?
Well, you've seen what happened yesterday, that there was this big, cyber attack that blocked, many websites and services. So I think that, we have to be, smarter than them, and then they become smarter than us, and then so on. So, it's still not clear how to avoid all these, attacks and intruders, into systems. So, I don't know. I'm not an expert in cybersecurity, but, it's not clear to me that this can be easily stopped. Of course, companies can have their own, security walls and everything, but I'm not sure that this can be stopped. If the even very sophisticated agencies here cannot keep, secrets that they have, then it means that, we still have a long way to do.
But I thought some of the sense of your question was about among those 5 companies,
Well,
can they share while still remaining competitive? And I think the answer is yes.
Yeah,
Companies can find ways to share and compete at the same time.
Yeah, but of course they don't share. The sharing is advising, sharing best practices, discussions, issues of concerns and so on, how to best develop AI, how to be ethical while developing AI, from the idea to the product that you get, and how to build these products in a way that that product is going to behave ethically when given to the world, and is going to behave in the best way for benefit of society.
I can imagine standards developing as well.
Yeah.
Going again back to science fiction, you can think of Isaac Asimov's 3 laws of robotics, and these were cooked in at the very foundational level into each robot. And maybe we would develop something like this, and through the combined power of these 5 companies, they could all adopt this and then kind of exert pressure on the rest of the world community to do the same.
Yeah, the standards are very important. Of course, it's not that 5 companies or even 10 or 15 can build a standard. It has to, be reached by consensus building. But over the course of the history of the technology, I think the information technology, especially, the standards have played a very big role in making the technology available to everybody. Because the fact that all the things are compatible, like, the standard for the Wi-Fi. At the beginning, there was no standard, and then by consensus building, in our computers, in our telephones, we all have the same system with the same protocol, being able to connect to any Wi-Fi in the world, because it uses the same, methodology. So, of course, it cannot be that precise or technological-oriented standard that tell these companies or everybody else how to develop AI in the right way, but there could be, very precise guidelines on how to do that. And that's, one of the things that we think that would be very important to achieve.
It may not answer the limit case that you brought up of a war or something like that, or even just a big military rivalry, but it's a lot better than nothing.
Yeah, well, I think so.
Yeah.
I think it's very promising, and I think that the fact that it comes from companies has to be interpreted in the right way. It's not that these companies want to decide how AI should be done, and they're going to get together and define it and so on, but because companies are those that are closer to understand what it means to deploy AI system in the real world. Because they have clients, and these clients actually use AI in the real world. And those are the people that can tell us what are the issues that you see in healthcare, in finance, in retail, in e-commerce, and so on. So, and so tell us, and these are the issues that we are going to address and resolve. What are the problems that you see once you get your product and you just, give it to customers, So that's where it should start, this discussion. And then everybody else should be involved as well.
Speaking of everybody else, you mentioned the 5 companies. Are you in this organization making efforts to bring academia into that discussion?
Yeah. Academia, non-profit organizations, and other professional associations, everybody, we just have to understand how to put together the puzzle, to make everybody be part of the discussion in the right way.
According to Yann LeCun, who's at NYU and also runs the deep learning part of Facebook, at least at the moment, there are no secrets as far as how to make an artificial general intelligence. So at least his story is the academic research centers are way better than the company ones. because none of the good people will work for an organization where they can't publish their results and collaborate with other academics who are working on the same thing.
You should not assume that companies cannot work with academia.
Well, of course, he's working with a company, Facebook.
Yes.
And he
point.
says, take it from me. The private efforts are just nowhere near as good as the academic public efforts. The best people are all in academic centers, even if they're also in Facebook. At least at the moment, the technology in public academic centers is ahead of the technology, the privately developed technology, where they don't have the benefit of getting feedback from a large public that looks at the code and.
But I mean, I don't know. I mean, I've heard Ian saying this many times. And by the way, Ian is also the Facebook representative in this partnership that I discussed. So he's also involved in that. And I heard him saying many times that, what is developed in academia is much better. But I don't know that at this point there is really a difference, because there is a lot of collaboration, and big companies, of course, that do not have research centers, they just want to develop better and better products. Maybe they don't share, they don't publish in academic venues, but other companies that have research centers like IBM, Microsoft, and others, and they do publish and they do collaborate with academia, and they do, and they want to be exposed to the feedback and to the comments, positive or negative, of the rest of the academic, colleagues. So. I don't see so much difference. And also, I mean, there are a lot of, data sets. Many are openly available, data sets on which these AI systems can be trained and can be instructed, but there is also a lot of data that companies can get access just because, that they have the real world scenarios they can work with. So I think that I don't see much difference between the two.
Yeah, I'd like to comment on your quote from Jan also. And I guess this is just a reflection of my own cognitive bias, because no one likes being implicated for being second rate. So I don't know actually what is the utility of making such comparisons. I think we should be embracing what academia and industry can bring to the table. I think there are outstanding people in academia. Obviously, Jan is one of them. There are a lot of other people that one can cite. I think something that so the individual technologies being developed, yes, they're outstanding. I think we're developing some pretty good things too, but one place where I think companies can really shine is weaving it all together into something that actually works and something that actually has an impact on the real world. So rather than saying A is better than B, I would rather focus on how can A and B work together collaboratively in the best possible way to create the best value for the world.
Yeah, and of course he's focused on that too.
Right, he has a foot in both worlds,
so he was,
as does Francesca.
Yeah, he was trying to combat the suspicion that you see that there's some nefarious artificial intelligence projects deeply hidden in some company that is going to take over the world or something. So he was speaking to that kind of issue. He's saying, no, it's not going to happen.
No, it's only going to happen in academia, not in industry.
Well, what he says is that it'll be public. So the point he was making is that it's public. What academics are doing is public. They publish it. They're at conferences. They, all that sort of stuff.
Yeah.
But I thought academics chronically complain, certainly in the medical biotech field and so on. They're constantly complaining that in research, that they don't have enough financial resources, and companies like IBM and so on have all the. So it's a little bit puzzling to me that that would be expressed like Jan is.
And I think this issue of resources is important, not just because you want to have more money to do your research, but because in corporate environments, especially big ones like IBM, you really, like Jeff just said, you really have the opportunity to put together experts in many different areas of AI or even IT or even other disciplines, and you put together software, hardware, embodiment, and not, so you really have the chance of putting together the best of all these lines of work to build something that is, even more, significant. And this, I think, rarely happens in a university group because of lack of resources, but also because within a department, you have a critical mass. Some people have it, but not as much as you can get, in a very big corporate environment. And you are not exposed to this wide range of applications that, for example, IBM can describe to us. If I want to know, or Jeff wants to know, what are the main things that are happening in AI applied to healthcare, or AI applied to commerce, or AI applied to anything else, well, within IBM, you find it. So while in academia, you have to, contact somebody else and see whether he knows, and then go to look at the conferences and this and that. In a big corporate environment, you are really exposed to, the real world, and so that's very important for Jan. For example, in Facebook, as a more narrow goal, which is whatever is important to Facebook in terms of AI, like personalizing the newsfeed or recognizing people or other objects or whatever, understanding what is in a picture, things like that. But I think that by being connected to Facebook, he really can do much more than what he could do by just being, big NYU professor is not just, but he really gets exposed to the level of, being exposed to the real world issues in a very wide reaching enterprise like Facebook. It's really very, important for him as well. I think he would not deny it.
Oh, he says so, yeah.
I'd like to follow up on 2 points. One, Ed, I think you said something about academia complaining about financial resources. Don't think that only holds in academia necessarily. Researchers are insatiable in their desire for financial support anywhere, academia or industry. The other thing is, one thing that on the point of collaboration between industry and academia and bringing together the best of both worlds, one thing I've been involved in is a collaboration in the space of embodied cognition that IBM started up with Rensselaer Polytechnic Institute about a year ago. We've been working with several professors there and their students to set up environments there, cognitive rims, like the ones that we're developing at IBM. And they're starting from the technology that we provided, and now they're really building some very interesting things on top of that. But the thing I want to emphasize is that I think what we brought to RPI in doing this was the idea of what these professors and their students could do if they worked together. They're not so accustomed to doing that, as I find. They have
to working with whom?
With other professors at the same university. They have their colleagues all around the world. They have their own social networks and all that. But they, by and large, tend not to work quite as much with people at their own institution. And so they haven't had the experience of building together a much larger thing than they can do independently of one another. And I think bringing that model of what we're able to do within a company to RPI has been, I think, eye-opening for them, and I'm hoping it is a good model for other universities and for other university industry collaborations.
I'm curious about what you two are saying about IBM. I have no real knowledge of industry, but the impression one gets just reading, and I have, I do have one other source, is that many companies are organized in informational silos, where the parts of the company really operate in secret from one another. Is that not true at IBM?
I
Jeff
don't.
can say more because I joined 1 year ago. Maybe I
They're
have
so well hidden, you don't know they
very
exist.
naive.
Yeah.
No, but I see a lot of collaboration, and again, more than my what is it? No,
Something fell down. I don't know what it is.
no.
You're okay.
You're okay.
No. So more than I see really in academia. You know, in my department, for example, I work in AI, and then somebody else works in other areas of information technology, software engineering or formal methods. But we all work with other colleagues in that same area, as Jeff said, but not much with other colleagues in other areas. So that brings maybe more advancement in your own area, but then when you want to build something, you actually need other disciplines. And within academia, you don't do that.
I'm
I don't
surprised
think
that
the silos are.
And I think that at IBM is needed instead, this collaboration between different disciplines, because otherwise you cannot build a product that goes into the real world from the idea and research and so on. So you need different people with different capabilities to be put together and to build actually that thing.
I've been at, yeah.
Well, it's funny because there's a parallel between what you're saying the AI needs to do to work better, which is to be embodied in the real world and grounded in the real world. And we're saying the AI researchers also need to be embodied in society and get that feedback. So
embedded.
I think that's been
embedded. Yeah.
I think that's been a recurring theme in this discussion. But just to comment on industry, or at least my own experience of it, there are always silos that develop in any organization. But I wouldn't say that, at least in my case, they've been intentional. It's more security through obscurity, I guess. In my own case, I've felt that in my quarter century or so at IBM, I've been able to collaborate very broadly. And in particular, our work in embodied cognition requires that, because our team by itself weaves together technologies from a vast number of other research teams working in our lab and in the other labs around the world. We need that. We can't do it all ourselves. And so we strive all the time to break down any barriers that, some of the barriers are time zones and things like this. We strive continually to try to break down those barriers, educate ourselves about what others are doing, and avail ourselves of those technologies.
So I'm surprised what you said about Rensselaer Polytechnic Institute, because at least in the parts of NYU that I'm familiar with, it isn't like that at all. So my colleague David Chalmers and I, who run the Center for Mind, Brain, and Consciousness, we both have joint appointments in neuroscience. I have a joint appointment in psychology. I go to lab meetings of some of my psychology department colleagues. Of course, I talk to all my philosophy department colleagues too. So we seem to have...
I think that maybe it's different
I may
in
have
the social
mischaracterized.
sciences.
maybe.
I think that maybe in the context of social sciences, maybe it's a bit less.
Yeah, sure. Have to go to one question, so people can line up at the microphone, and please speak briefly and to the questions specifically.
Thank you. Is it on? No? Is it on? Yeah. Okay, my question goes back a little bit toward when you were talking about emotion with AI, and then also with a possible threat toward people. And my question is, isn't there a fundamental difference between humans and artificial intelligence regarding concerns about mortality, and then to extend that to worry about survival of the species even? I mean, is a machine ever going to have that? Is a machine going to worry about if it ceases to exist? And if that's the case that it wouldn't, does that mitigate any possible threat that could occur down the road?
You know, one point that's sometimes made about this is that even if the machine doesn't care about its own existence, it might care about its project, and its project may require its existence, in which case it might act almost as if it was really extremely concerned with its own existence. The Sorcerer's Apprentice story is like that. So we're not supposed to imagine that the machine cares about its own existence, but it cares about getting the cauldron full, so it's going to protect itself from being destroyed.
And,
so it may not make
yeah.
that much difference.
And the
Is there
other
a specific
example
sub-
from sci-fi would be 2001: A Space Odyssey.
I was thinking of
Yeah.
that too. Yeah.
Yeah.
Hal had the greatest enthusiasm for this mission, and that
Yeah.
may have been the thing, rather than its own
Yeah.
self-preservation.
But is there
Yeah.
any self-preservation built in, or not really?
Not today. I don't know how it's going to go going forward.
Right. Thank you.
I was thinking of the metaphor you had of the castle and the wide, the wide walls and the high walls, and it hasn't been mentioned the notion of social systems. And I see the social systems, let's say Watson in the medical, being the castle, and then there's this moat, and I don't know how for example, let's say Watson has cures for this, efficient ways to do surgery, etc. And the social system, i.e., let's say the medical system, is with their gatekeepers, very protective, wanting essentially money or protecting their financial needs, etc. So maybe this is something in the future where people working with AI have to kind of deal with social systems, which is probably a whole different level beyond the issue of ethics, etc. So,
Yeah, definitely. I mean, to understand, the dynamics within social systems in order to support them, but also, to be aware of to understand what's the best way to interact with the social system. Of course, we don't want AI to be manipulating people or make them, believe something.
Well, let's say there's a type of surgery that Watson says, this is best surgery.
Yeah.
The social systems in, let's say, medical says, well, that's good, but there are other surgeries which essentially helps the finances of the surgeon. And you're going to have this kind of play that goes on. So I guess the deeper question I would say is, where would the role of the patient come in dealing with...
Hopefully, yes. Hopefully the AI system could be not just a support or like a consultant for the doctor, but it could also be something that gives, the possibility of engaging with all the stakeholders, the patient as well. And so that...
So you can empower the patient to deal with the power of the social system.
I would guess, look, right now there is the robotic surgery for prostate cancer. But in order to do the robotic surgery, you need a surgeon. It seems to me over time, if the robot could do the surgery without the surgeon, you would start not having urological surgeons specializing in prostate cancer. They would just, over time, drop out.
Well, make it really, just a very personal experience. I had to, trying to find a surgeon to do some certain non-invasive surgery. I've gone to 6 surgeons, finally found the 7th, who wanted to do a more traditional surgery. This is over a 2-year period. So when you say over time, I'm talking about a system. And the system, to change the system, is, I think, a variable that I assume somewhere along the line you're going to meet up with. And the robotics is fine, but a system that's based on different values than maybe you taught your robot or Watson to deal with, there's going to be a gap or a conflict. That's all I'm suggesting.
There's another aspect implicit in what you're saying, which is the rise of automation in general. Mm-hmm. And AI is going to probably accelerate that and feed that process. And when you talk about the rise of automation, higher level, either robotic or AI assisted technologies, interacting with a system that has certain established patterns for humans to be carrying out certain functions, and livelihoods are built on that. It seems that one of the very hard to avoid pathways with rising automation is ever increasing unemployment. How are people going to react when Google self-driving trucks and cars, millions of people immediately out of unemployment, taxi drivers, everybody else. And now start imagining AI, this fundamentally beneficial, well-intended technology spreading throughout various aspects of our economy, and you have half the population no longer able to be employed. That's it's a broader version of the case you're bringing up.
Well, the surgeon was making $500,000 a year. Well, now we're making $100,000 a year. He and his professions, like the craft union, not unions, during the 18th century, they're going to put up barriers, that's all.
Well, you end up with one surgeon making the same amount as that surgeon makes today, bots doing the surgery, and all the others will be out of work.
In my case, this surgery, maybe they made $1,000. The other surgery, they were going to get $5,000. So they didn't want to hear about this surgery.
Well, here's how I would see your scenario playing out potentially. The surgeon may have some opinion and have some recommendations. The surgeon might be assisted by some AI agent looking at things from the surgeon's perspective. The patient could listen to the surgeon, maybe go to a couple of surgeons, and have their own AI advisor saying, well, here are the trade-offs. You could do this surgery, it's only $2,000, and your new leg will last you 5 years. Here's a surgery for $10,000, and probably it'll last a good 15 to 20 years. It's up to you to make that choice. And then the surgery itself, as an embodied AI, a robotic surgeon might assist the surgeon or do the surgery all by itself. There would be decisions to make during the course of that. So there are all sorts of different levels at which embodied AI could play a role in the scenario that you outlined.
I'm just saying, if you deal with the social system, let's say the medical social system, to create change is going to be very difficult. I've had this experience. So A surgeon goes to B surgeon, or I go to A, and then it goes to B surgeon won't see me because A surgeon says this guy is asking something that we won't do, and he goes to C surgeon. So I'm trying to say there's a social system built into certain professions. It's like the old guild, and they want to protect themselves. So somewhere along the line, you're going to interface, theoretically anyway, and these are going to be the issues. When you affect people's money, especially really ingrained groups of people, like, let's say, medical professionals.
We have other questions also. Thank you.
I have a lot of questions, but I would like to ask two. First, I heard a couple of years ago, I heard about cognitive rooms, but not from that developed not in IBM, but with genetic engineering. And it was from a guy who was talking about that they, for example, grow human eyes on mice, and next stage of the experiment, it's like making cognitive buildings or rooms. And my question is, what do you think? Should we stop to be afraid of domination of robots and start to be afraid of domination of our buildings and our, like that they control and dominate world and devour us and kill us? What should we do? It's first question.
Well, I mean, I don't see there is really a sharp, boundary between a robot and the building. I mean, with the Internet of Things, everything will be connected. Our fridge, our TV, our car, the traffic lights. They will all be communicating with each other to help us live better.
But not be afraid. We should not be
Well,
afraid.
we have to make sure that this thing is built in a way that it should not harm us, so they that they just build it and it goes by itself, that there are no undesired effects. But I think that, we have to work hard in making it in a way that is going to be, helpful,
So not fear, but calm awareness.
Yes.
Thank you. Maybe
Could I-
if you have a number of people who can ask the second question after.
Hi. Slightly complicated question, but I'll try to keep it brief. You've been talking about how the end goal of artificial intelligence is to create a system that has agency, but in the short term, we're talking about building systems that have, implementation, things that are used as tools to an end. So in the meantime, before we reach some sort of human level consciousness, you're probably going to be working, at least at IBM, to design products that use artificial intelligence and are bounded and embodied to some degree by whatever it is that they are placed into. So I guess what I'm kind of curious about is if the end goal is a system that has like general principles for understanding and applying to the world as a whole, how the different kinds of embodiment are going to affect an artificial intelligence system. Like, for example, if you put one in a car, how will that shape the way that the artificial intelligence looks versus if you have one that's like a maid in a house, as you were talking about, or a room? Because surely that would have some impact on the way that the system thinks and, cogitates. That's
Yeah,
it.
definitely the kind of embodiment is going to be very, is going to impact on the way the system will learn over time, because it will also dictate, how it will interact with the environment and with the humans, and also, the kind of, to go back to this, the ethical, concerns that you may have with the companion robot for elderly people, or with a self-driving car, or with a cognitive room to make, a highly decision are very different. So, so it's not clear, to me at least, the relationship between the kind of embodiment that we choose and, how to build in the best way the software that is going to be, and the behavior of that machine.
The embodied AI that we build and apply in different environments, so that they will be different. I think a lot of the components will be similar, but they'll be woven together. I think we'll also have a common architecture, but still the end product will be different in different cases. And I think there is a lot of engineering and design to be done that takes into account how humans use these technologies. And we do have a number of people who are concerned with this aspect. To study, we design these tools with an awareness of the way humans are and the way humans like to use things. We build the tools, we probably don't get them right, and we iterate until we find that they are indeed useful.
Thanks.
Toward trying to further humanize AI, it's making the interaction phase better. Do you know of any projects, research of a serious kind on three things? First, software, trying to write really good jazz, given a theme. Is that working on? Secondly, trying to write a sonnet, given a theme. And then on hardware, trying to juggle 5 balls. Is there any serious progress work on that?
Okay, so on the music, I know projects. For example, Sony has a research center in Paris where they actually are building, original songs in the style of some bossa nova or jazz or whatever. And they are trying to use AI techniques to make sure that the song is original enough, but is recognized to be according to a certain style. Like very recently, they released a new song in the style of the Beatles, And that, I think, I listened to it, and yeah, if you didn't know all the Beatles, that it was not a Beatles song, you could say, yeah, maybe it's not one of the best ones, but I think it was, a pretty, reasonable new song, and jazz as well. So you may want to look at what they do there, because it's really interesting stuff. And the AI techniques are there to make sure that the song is original while satisfying some constraints that you need to satisfy, for example, in jazz or in the different styles that you may want to use. And so that in that case, I think there are these and other people that are working on that. And in general, there are people working on making AI applied to creative tasks in general, not just songs or sonnets. Like even doing a portrait, I've seen AIs doing portraits, and that was very, impressive. Like it was a room full of robotic arms that were, looking at one human. They were all looking at one human. They were making a portrait, with the pencil of that human, and they were all these robotic arms. They were all, each one was doing a different portrait. That was the impressive thing. It was very nice portrait, but each one was different from the other one. So there was some sort of creativity, or so there are people working on that.
But I see those technologies as components that being able to compose good jazz, or Brandenburg Concerto No. 7. I think, to me, that's a component that's not necessarily an instance of cognition, but very clever work on statistical characterizations of music and then regeneration. Certainly can be components of an embodied AI. With regard to juggling, I don't know particularly there. I do know that there have been examples of balancing the inverted pendulum like that. If the robot capable of juggling 5 balls doesn't exist today, I don't see any real barrier to being able to accomplish that.
I'm sure you know Ron Graham.
Yes, he did 5.
He thinks it's just about impossible for a robot, but who knows? Yeah.
I think Ron Graham was capable of doing 5.
Ron can do
yes.
it. He can do it. He can also balance on one hand. Yeah.
Mm-hmm. But I think I have no concern about robots being able to get there in the reasonable future.
Thank you. Go ahead.
Hi. So before you were talking about how the best way to develop AI might be to almost raise it as a child, or to teach it so that it can make logical assumptions and that it has a background. I'm curious, at that point, wouldn't you be concerned about the AI developing the same biases that you were originally trying to avoid?
Well, presumably you would be needing it to develop a similar set of assumptions. You would then have to educate it that certain biases are not socially acceptable. I mean, socialization is the accumulation of all this background knowledge that's not only factual, the floor doesn't come up and bite you, but it's also normative in the sense that you should do this under these circumstances, but not in that context. And so it would develop what we could call what it's developing biases, but that's the necessary texture of that background knowledge base that it needs to operate intelligently in the world.
Yeah, I think these biases, it's possible that a robot being taught to live in this world might develop cognitive biases. Would they be the same set of cognitive biases that have been observed in humans? No, it might be things that's from ours. I would hope that we would be able to correct those things and get it to think in a less biased way. But you're right that I think we humans, we develop shortcuts. There's a certain way our brains are wired. These these biases, I think, are a form of heuristic that work in a lot of cases, but not in all cases, and they sometimes get us into trouble. So these, embodied AIs may well develop something like this.
So some
Just different.
biases are just involve sensitivity to background frequencies. So here's an experiment that shows this. Subjects were asked to judge the height of various people standing next to a standard object in a college campus. The people were men and women, where the men and women were unknown to the subjects. There were matched pairs. That is, for every 6-foot man, there was also a 6-foot woman. For every 5-foot woman, there was a 5-foot man. And there was a bias towards judging the men to be taller. And that is because of sensitivity to background frequencies. Now, if you want of course, the trouble with sensitivity to background frequencies is they can intrude in an unjust way. But if you want your AI to be sensitive to background frequencies, you will have to do something about it in the way that we try to do something about human judgment.
But wouldn't you say also that the AI, in order to be properly functional, has to have that sensitivity to background frequencies?
Yes.
It has to generalize.
Yeah.
And make categories.
I would hope we could build into it a much better facility for dealing with probabilities and conditional probabilities than we possess.
Yeah.
If we say that humans are still evolving and that human evolution is linked with machines and AI, then kind of in the same way that when photography came along and freed painting to do other things than represent the world. So it seems like AI has the capacity either to stifle or to enhance this human evolution. And maybe some of the ways in which we could evolve are toward a greater sense of personal fulfillment, artistic creativity, lots of things. So is anyone looking at that? I mean, if you're telling me my preferences or you're notifying me every time I'm daydreaming, is that going to stifle?
That is going to happen. We are in a co-evolutionary relationship with the technologies we develop, and it's going to happen in this case as well. I think in small ways, we can start with small ways to answer the question of is it happening now or is it soon to happen. I think you can look at cases like assistance for the elderly that could be developed, where imagine you have an AI-enabled walker that helps grandma understand that she needs to lift her feet a little bit more, and by doing that, she might learn a better gait, such that maybe she won't need that walker anymore, at least for a while. So there are ways that AI can train us and help us in ways that ironically make us less dependent on those assistants. That's just a small thing, but I think imagine that we used to be a lot of people used to be very good at riding horses, and now I think that has atrophied. But there's probably something changing in our brain that makes us that distinguishes us from people from the 1800s. Where we're better drivers than they would have been. There's something that has changed in us. And I think this is happening in small ways already and might happen in very large ways, maybe more explicitly as we start to more explicitly implant devices in ourselves that are designed to enhance our cognition.
Thank you.
Okay, my question is, have there been any experiments long-term, or have there been any successful or not experiments with long-term training of artificial embodied beings? Or AIs, embodied AIs, like, you know, long-term training, like broader intelligence and not just focus in a billion cases just to learn as a very specific task?
Well, there are some people that work on more general AI rather than narrow and specific to the task. Like, you may be aware of these people at this company called DeepMind, which is part of Google, and they have this, you know, algorithm that can learn how to play many different games on the screen. Okay, just by looking at you know, how these games are played, just by looking at people playing these games. And so it can learn not just one game only, but many different ones, even with different, you know, rules, different, you know, score functions, you know, accumulate a score in the game to win and so on. And so without communicating the rules of the games to this machine, the machine learns just by observing many different ones. And I think that that could be, you know, one. Of course, it's very specific, just games. It's not real life, it's not, you know, very realistic scenario, but they claim that that could be a way to, you know, build a machine that can learn to do many different things that work according to different rules. But there are also other people that, I mean, whose goal is to work more on general AI rather than a specific one, but this is one that came to mind. I mean, that they are, you know, working hard in expanding that.
We have only 4 minutes, so...
I just want to be more specific because
Okay.
it was not exactly my question. I mean, I know people have like have chimps from babies and they train them like 15 years. And my question is more like if there has been experiments, successful or not, like training AIs for 15 years from nothing to something.
15 years ago, AI was very different. The world was very different. I mean, AI just was started, you know, not long ago, just 50 years ago. So I think that I'm not aware of these long, you know, training, you know, experiments.
I think there have been some attempts to learn some simple tasks with computer systems that are modeled after the brain. I remember some work that was done at IBM probably 10 years ago now that wired together a bunch of pseudo neurons into something akin to the mini columns that are in one part of the brain. And I think they were trying to teach it to just, to train a visual system. Can you recognize something? Just, here's a bunch of circuitry, and we're going to put a bunch of images in front of you, and can you learn it? I don't know how far it got. I haven't, but I know that there have been attempts in other research institutions as well to do this, but I don't know what was the outcome of these.
Thank you.
So one point I haven't heard raised has to do with the tendency of the goals to be redefined as a function of the available solutions rather than the other way around. So, for example, Facebook has redefined the notion of friendship, and I'm not convinced that it's an improvement on the earlier version. And for that reason, it's important to me, it seems, that the question of democracy be addressed. And what I've been hearing about the likelihood of half of all employment being eliminated, and the question is, are the people who are likely to be affected by that actually being consulted, and is this decision to be made purely on the basis of the availability of enormous resources on the part of the corporations in Silicon Valley, these 5 corporations that were mentioned and the ones that were not. My colleagues at Stanford tell me they overhear conversations in the coffee shops, and people are very, very, very seriously discussing what they're going to be doing with all these unemployed people, and they feel concerned about it. What I'm more concerned about, the absence of restraint on the part of the people who exercise this power and who have these resources, rather than the likelihood that machines will get out of control.
Yeah, I think there is a lot of discussion also in terms of regulations of AI, possible regulation, and I think that, for example, a few days ago, the White House released a very interesting document on the future of AI and the strategic directions on how to, with the goal of, facilitating the good development of AI and possibly mitigating the undesired, consequences. And I think that, so even last week I was speaking at the European Parliament, and people there have very concerns about some specific issues about AI, like data privacy, ownership, things like that. But they also are concerned about, to understand how to regulate this very powerful technology in a way that it does not stop research and, beneficial advancement, but also it addresses these other concerns, like, for example, the impact on the workforce.
Well, the European Parliament is not a notably democratic body in the European Union as a whole. And the question is, where is the, how is the public that is going to be most profoundly affected taking part in the decisions?
I think there are some economists who are thinking about the impact of AI on the economy and displacement and the like. I think Eric Brynjolfsson is one such person at MIT, and there are others. And I think it is important to explore these questions. I don't know if we have good answers right now, but it's one of those things that we have to be conscious of and think about and integrate into our thinking.
One historical example is in the 1930s, Gandhi's campaign to resist the industrial encroachment